Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the A-level mathematics subject of the cosine rule. So what is the cosine rule? So if we have a triangle with sides little a, little b, little c and angles a, b, c, cosine rule says that a squared equals b squared plus c squared minus 2bc cos a, where a is the angle. So this is actually a generalization of Pythagoras' theorem, because when a is 90 degrees, then this term at the end becomes 0. And so if a is 90, so that means that this would be the hypotenuse, and you just get a squared equals b squared plus c squared, which is the Pythagoras theorem. So this is actually a generalization of the Pythagoras theorem. It allows us to work out all of the angles if we're given three sides. So if we're given three sides of a triangle, all the angles must be determined. I mean, if someone tells you the three sides of a triangle, that determines the whole triangle, including the angles. So you got a squared equals b squared plus c squared minus 2bc cos a. That's just the rule. So what that means is that cos a is going to be, just rearranging the formula above, b squared plus c squared minus a squared divided by 2bc. So a is the inverse cos of that. And you can do that for a, you can also do that for b and c. There's similar formulas for b and c. Actually, you can do it for a, you can do it for b, and then you can work out c, because you know that the angles of a triangle add up to 180 degrees or add up to pi radians. So you've just got to take a and b from 180, or take a and b from pi radians if they're in radians. You can also use the cosine formula if you want to. So this is really important, because up until now, sine, cos and tan have only kind of made sense in the context of right angle triangles, and now we're applying them to all sorts of other triangles. So given two sides at an included angle, we can work out the length of the third side. So if we have two sides at an included angle, it specifies the third side. So a squared equals b squared plus c squared minus 2bc cos a. And we know all of the things on the right. So a just equals the square root of b squared plus c squared minus 2bc cos a. So how do we prove the cosine rule? So firstly, just by definition, cosine c equals a2 over b. And then we've got two applications of Pythagoras' theorem. So h squared, which is h squared is part of a right angle triangle here. That's b squared minus a2 squared. And it also equals c squared minus a1 squared. Both of those are by Pythagoras' theorem. So b squared minus a2 squared equals c squared minus a1 squared, which means that c squared equals a1 squared minus a2 squared plus b squared. And then what we're going to do is we're just going to factorize this by a difference of two squares, a1 squared minus a2 squared. And then basically what we've got here is we've got minus a2 times a1 plus a2. And we're going to change that to plus a2. But by doing that, we have to take off 2 times a2 times a1 plus a2. So basically, if you take off 2a2 times a1 plus a2, that will then make this into minus a2, and it will be the same as the above. And of course, we put plus b squared on the end. The reason that's important is because on the front, what we've got is a times a, which is a squared. Then we've got minus 2a times a2. So a1 plus a2 is just a. So it's minus 2a a2 plus b squared. So then what you got is c squared equals a squared plus b squared minus 2a times a2. But a2 from up above, a2 equals b cos c. So what you got is c squared equals a squared plus b squared minus 2ab cos c. And as if by magic, the answer appears. How did we do this? Well, we kind of did this. Firstly, we drew a general triangle, ABC. And then within that, we set up a right angle triangle with C in it, so we could define cos C. And then this right angle triangle required a kind of perpendicular here. And then once you've got right angle triangles, Pythagoras is a very natural thing to do. So it just kind of, then we did some algebra and it just kind of fell out. So let's look at an example. Say you've got a 3, 4, 5 triangle. So we know this is the formula here. We're trying to work out the angles in a 3, 4, 5 triangle. So we know that 9 equals 16 plus 25 minus 40 cos A. So 40 cos A equals 32, because basically we add 40 cos A to both sides, and then we take 9. So this was 40. This was 41 minus 9 is 32. 40 cos A equals 32. Cos A equals 32 over 40 equals 4 over 5. So the inverse cos of 4 over 5 is 36.87 degrees, or 0.6435 radians. I said that quickly, didn't I? Let's do the next one. B squared equals A squared plus C squared minus 2AC cos B. So here you've got 25 equals 16 plus 9 minus 24 cos B. So basically you've got 25 here and 25 there, so cos B equals 0. B equals 90 degrees, or pi over 2 radians, so it's a right angle triangle. Then you can work out C, because basically 180 minus 36.87 minus 90 gives you C, 53.13, or 0.9273 radians. Okay, let's look at another one. We can work out the side given two angles and a side. No, this is wrong. We can work out a side given two sides and an included angle. Look at that, we're correcting this in real time. And an included angle. That's the whole point. So here, A squared is the side we're trying to find, and then you got 4 squared plus 2 squared minus 2 times 4 cos pi over 3. So A squared equals 20, which is 16 plus 4, minus 8, because cos pi over 3 is a half. That's the point. Cos pi over 3 is a half, so this is just going to be 8. A squared equals 20 minus 8, which is 12. A equals the square root of 12, which is 2 root 3. I hope you like this. I really like doing it. Yeah, please do subscribe and hit the notification bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.